Number 95, is it geometric or not? So, I think we are going to check bits on this one. So, binary. Well, you have the situation with serial boxes and NASCAR drivers, and there's a 1/5 chance that any particular driver's cards ends up in each box. So, sounds like they put the same amount of each driver's cards in the boxes, so you don't have a better chance for one driver or the other. Now, we're going to assume that each of the boxes are independent. They have nothing to do with each other, whether you win or not. The success rate is the same. Like I said, equal number of drivers in all those boxes, so 1/5 chance for any driver. The trials is not going to work because in a binary situation, we keep going until we get one success, and then we stop. This time we would have to get all 5 drivers, so this one does not work for geometric. Letter B. Okay. Letter B, same thing. Bits. Well, the binary is she's just gonna, she either wins or she doesn't win, right? So 2 or more, she has a 0.259 chance of that of winning, right? Or not winning. Now, independent. Each game that's played has nothing to do with the game before. The trials, that's okay because she's going to say, I'm going to just keep doing this until I win. That's it, okay? Keep going until I win one time and then I quit. And then the success rate is the same for each game because she plays that, what is it, the 4 spot, I guess they call it. She plays the same way each of the games. Okay, so yes, that does work for a geometric setting. All right, there's that one. Number 97. Now don't forget that if you have trouble with problems like this and it has that symbol, it means that there's an example in the book that's just like this problem. Very helpful. Geometric random variable. Now I think of geometric random variable as like when people say, when they lose something, right? And then they come to you and say, wouldn't you know it was in the last place I looked? Well, that kind of makes sense, doesn't it? Because when you just stop looking at the last like it's going to be in the last place you look because that's where you found it. I mean, wouldn't it be weird if somebody said, it was in the third to last place I looked because I found it and then I looked in 2 other places and it wasn't there either? It just, what? You could just keep looking until you find it and then you stop. Geometric. All right, number 97. So like this one, Rita has to pull a cord and hope that for her lawnmower, there's a 20% chance of starting it. It doesn't make sense if she started it that she would continue trying to start it. Anyway, sometimes people, I tell you. Well, let's figure out the probability that takes her exactly 3 times. So the probability that y is equal to 3. Well, let's see, 3 times, right? So 80% of starting it, right, takes exactly 3 times. So there's an 80% chance of not starting it, right? So 80% chance of not starting it, which means you would have to do that twice, and then on the 3rd pull, she starts it. There you go. That's how we figure out the probability. Wango. And I'm going to go down to geometric PDF just to plug it in. So the probability of success is 0.2 and my x value is 3. And it tells me that the answer is 0.128. So there's about a 12.8% chance that she's going to start this thing on the 3rd try. So find the probability that it takes her more than 10 pulls to start the mower. So that's, okay, 11, 12, 13, 14, forever. So let's figure out what if she starts it on the first pull, or the second pull, or the third pull, or the fourth pull? And we got to do all those probabilities all the way up to 10 pulls. Oh, you know what we should do? What if we just said, what's the probability that y is less than or equal to 10, and then subtract it from 1, right? Because that would give you everything else. So this one is going to be, what is it? Geometric CDF. Geom. CDF. Because that'll give us all of the probabilities for 10, 9, 8, 7, 6, 5, all of them added together. So we'll get rid of that, and whatever is left is going to be more than 10 pulls. So I'm going to put that into the calculator. So when I put it in the calculator, I got 0.89. 0.89. So that's the probability it's going to take anywhere from 1 to 10 pulls. But we want to know it takes more than 10 pulls. So we're going to take this and subtract it from 1. 1 minus 0.89. And what do you get for that? So what is that, 11%? So there's an 11% chance that it would take more than 10 pulls to start this mower. There we go.